All right, so if you stuck around, it's because you wanted to see some examples. As I said before, this is pretty straightforward, pretty easy stuff, but it is word problems, and word problems are terrible sometimes. So we're going to look at some practice word problems. Make sure that these can be seen. Okay, as you can tell, there's a couple of things I need to do in this problem. I'm just looking at number one, which I realize now that I need to move and actually have paper to work because I didn't leave myself enough space. All right, so if you look at just number one, I feel like that's crooked. There we go. You'll see that there are some things that need to be done to this practice. First of all, 15.0 milliliters is in milliliters and needs to be in liters. Then you've got 25 degrees Celsius, which needs to be in Kelvin. And then you've got another pressure in there. So that starts throwing us off. It's like, uh-oh, what's the pressure for? Because you talked about temperature. Well, it seems that the pressure is unimportant in this case. And that tends to happen with a lot of these laws. They start throwing in extra stuff that you don't need just to confuse you. So we're looking for the pressures. We're looking for the volumes and the temperatures, and that's it. So 50 milliliters at a temperature of 25 degrees Celsius, 35 degrees Celsius. What's the new volume? So they're looking for V2. So I don't need that. I don't need the pressure. The pressure is just extra information. So we have 50 milliliters. And we're going to need to turn that into liters. If you remember before, milliliters are on top, milliliters on the bottom. There's 1,000 milliliters in every 1 liter. Or you can do the whole, move the decimal place over 3 places, whichever works for you. And then to calculate the temperature change, we've got 25 degrees Celsius. And if we want that to be in Kelvin, all we do is add 273. All right, so this one's 0.05 liters. This is 298. I'm scared to trust my math this late at night. It is 298. Whew. At least I can still do math. All right, and then we have 35 degrees Celsius, and that needs to be converted as well. I'm just going to go ahead and use the calculator. And that's going to give you 308 Kelvin. So all I did was get everything into something where I can manipulate what I need. I'm going to move that for now so that you guys can see the actual work. All right, so we have V1 over T1 equals V2 over T2. We are currently looking for, remember this is our T1, this is our T2, this is our V1. We're looking for V2. That's our question mark. See if I can turn a light onto this. Does that help or make it worse? It helps a little. I'll keep it going as long as it helps a little. Our first step is to cross multiply. So we end up with V1 times T2 equals V2 times T1. Once it's in this format, it's exactly the same as Boyle's law. So we're looking for V2. So I'm going to circle V2 because that's what I'm looking for. And I'm going to divide by everyone else, which is T1. This goes away. V2 equals V1 times T2 divided by T1. All I do is plug numbers in now. V1 is up here, 0.05. So 0.05 liters. Don't forget to put your liters. Guys, when I'm telling you to show your work, this is the stuff we're looking for. This is what I'm looking for. Times T2. T2 was 308K. Divided by T1, which was 298K. You will notice that at this point, I cannot do any math. There's nothing I can do with this math. until I cancel those units. Kelvin is now canceled. Now I can do math. So 0.05 times 308 divided by 298 gives us 0.05 and liters. So it looks like the volume stayed the same, unless I did bad math. I'm just going to check it one more time, because usually it doesn't stay the same. Still got 0.05. So alas, here we are. B2 is the same at 0.05. This should get you started, should get you going on your problems. You only have 10 problems. They're not super ridiculously complicated. Miss you guys. I hope you guys are staying safe and doing what you need to do in this social distancing.